In the last section, we attempted to make use of the text operator inside of our Mongo query to find a user with a very particular name. When we executed that query, we saw a big error message pop up that said text index required for text query. So clearly there's something wrong here, and frankly, I think we deserve an error message because we just copy pasted a bunch of code without reading any of the documentation. So we'll say this one's on us, or I guess me. I'll take the blame for it, don't worry. So let's figure out a little bit about what this error message is talking about regarding this text index. An index is a system that Mongo uses to make very efficient queries whenever you're looking for data. That's what an index is. Let's look at an example or two. Inside this diagram, I have reflected a collection that we're going to call the users collection. The users collection has a big old list of users. Whenever we create a new collection of data, like the instant that is created in Mongo, an index is automatically created on the ID field of every record. So separate from the collection of all of the different records inside of the collection, separate from the big old list of users, is a bucket of indexes. And personally, I like to say indices, which I think is more accurate, but Mongo internally calls it, or their documentation refers to it as indexes specifically. This collection of indexes that sits inside of our users collection enables us to make very fast lookups to the ID field of every record. So in theory, whenever you call a function like, say, find by ID, and we try to find a record with a very particular ID, because the ID property of every record is indexed, we get a very fast lookup. The ID property of every record is indexed by default. So every collection we make automatically get an index on ID. If we want to add in very fast lookups for other properties on any of our objects or any of our records, we have the option of creating our own index. And we can do so by using the Mongo command line tool. A very common use case of creating your own index is whenever you have a certain property that you find yourself making many queries for over time. A very good common example of this might be an email field of a user. So we can imagine that every user maybe has an email. Maybe we want to very frequently make queries over our collection of users that involves the email field. So if we want to make sure that query is very quick, we can add an index for the email field, which would look something like, if I want to just specify it or recognize it via diagram, looks something like this. So we would add in a index on the email property of all of our different users. And that means we can make very fast lookups on anything that's involving the query. Involving the email. So when we look back at the message that we saw right here, it says text index required for text query. This means any single time that we want to use this text operator inside of our collection, like as we just did, we must specify a field that will be indexed as a text field. And so if we even look back at the query that we made inside of our search artist file, this starts to make a little bit of sense. You'll notice that in this line of code right here, we never actually specified that we wanted to look at the name of each property, did we? And we never actually said, okay, out of every artist, look at their names and try to find a name of criteria.name. Criteria.name right here is the value that we're looking for, and it's not actually specifying the field that we're looking at when we're trying to find the appropriate name. So in order for us to use this text search operators, we must first create an index on the name property of our artist collection. Once we add in this index property, once we add in this index on the name property, we can then make text searches on that property. The one really big thing that I want to mention to you about text indexes specifically being used for search is that Mongo currently only supports an index on a single field. So in other words, it starts to get a little bit more challenging if you want to say have an index that is made for searching on both an email field and a name field. That's when things start to get a little bit more hairy. So inside this section, we're going to go ahead and add an index on our artist collection over the name field. And once we do that, we should then be able to pull off our actual query. So let's add on our index. To do so, I'm going to open up my terminal. So here's my terminal. I'm inside of my project directory right now, and I'm going to start up my Mongo shell. I can do so by running the command mongo, like so. You'll notice that when I run the command mongo, it automatically connects to my test database. Now, I have a test database. If I look at my RoboMongo UI, I have my test database, but I don't really want to be in the test database. I want to be working on my upstar_music database. To change the database that we are currently operating on, we can run the command use upstar_music. That switches us to use the currently active database of Upstar Music. Whenever you're inside the Mongo shell, you're always operating on a single database at a time. So you always want to make sure that you use the correct database. If you want to get a list of all of your active databases on your current machine or the Mongo instance that you're connected to, you can run the command show DBs. This will show us a list of all the different databases that we have running on our current machine. So now that I'm connected to upstar_music, I can create a text index on our artist collection on the name property specifically by running the command db.artists.createIndex, and then we'll pass in an object with a key of the field that we want to add the index to, which for us is going to be name, and then a value of the type of index that we want to create. So for us, we want to create a text index. So then I will close off the object, close off the function, and then we can run it. After this command runs, we'll get a little bit of output that specifies a little bit more about the results of the operation that was just taken. So we have a variable in here that says number of indexes before this command was run. There was only one. Now that we've ran this command, we have 2 indexes on this collection, and then we get a status code of, okay, like everything went along A-OK. So now that we've added in our collection to the name property, we can now flip back over to our application and give a test to searching for a very particular artist. I'm going to first refresh our application by hitting Command R, just to make sure that I refresh the connection to our Mongo database. Once the application then loads up, any second now, there we go. I'm going to again do a search for a very particular user. So I'm going to find the name of one of my artists. And sorry, I said user, I meant to say artist. So I'm going to search for Don. I'll submit, and all right, looks good. I found specifically Don. So now if I clear everything out, submit again, and I'm back to my full result set. One thing that you're going to notice very quickly is that if I do a search for like only a portion of a name, like let's say, let's just put in the letter E. How about that? Let's search for E. You'll find no results found. And so this behaves a little bit not like what you might expect as far as full text search goes inside of Mongo by default. So by default, whenever you're doing a search, it is looking to match an entire word, like Don. So for example, on, just AWN, is not going to be matched. We can try out DAW, and yep, not going to match as well. But if we put in Don, all right, there we go. A little bit more like what we expect. So now that we've got text search in here, we can mix and match these different search operators together. And let's look for Dawn now. And she's outside of our criteria, and so she doesn't pop up. After we finish up with the last query inside of this sample project, we're going to seed our database and add in a couple thousand different records. And so searching and filtering is going to start to have a lot more sense than when we just have this limited list of 12 or so records. Okay, so this is looking good. We've got our text search wired up. We still have a little bit of work left to do as far as queries go inside our application. specifically around setting the set not retired and set retired flag for each of our artists. So let's continue the next section and implement these last two queries. I'll see you in just a second.